Hello, I'm Paul Beckwith, and in this video, I'm going to talk about the unbelievable extreme weather event that just occurred in Spain. The torrential rains amounting to almost a year's worth of rainfall in, 8, 10, 12 hours in parts of Spain, which led to catastrophic flooding and tremendous damage and loss of life in Valencia. This type of event has the signature of climate change all over it. So first of all, I'll show you in this graphic, you can see the jet streams coming up here, and you can see, it's pulling air, and there's a high pressure area of heat over here, and there's a heat dome over here. So basically the jet streams coming up here, separating colder air northward from warmer air southward. The air, this is high elevation, very, very fast winds, which sets up a lot of the weather patterns. And we can see it pulled air along here, which then looped back here. So there was a high pressure area here of warmth. And the jet stream had actually split. There was a lower latitude jet stream coming up here, creating this massive heat dome. So these heat domes are like mountains, if you like, and then the low pressure areas are like valleys. And this is called a cutoff low. The air circulation is clearly moving this way, right? In the northern hemisphere, when air moves into a low pressure area from a high pressure area, it deflects to the right because of the Coriolis force. So it circles this way, counterclockwise. And this low is essentially cut off from the colder temperatures and lows elsewhere. So it's called a cutoff low. And basically this pattern repeated, and there was a lot of moisture coming upwards to Spain from this direction, and also being carried down this way from this direction. Huge amounts of moisture. And in these cutoff lows, in low pressure areas, you get storms and raininess. So this happened, and we had torrential rains over large parts of eastern Spain, and it caused, massive amounts of water went on the ground. Spain's generally fairly dry country, and the soils weren't able to keep up. There's no way they could keep up. So the water sat on the surface and became overland flooding, and it went to the low points, and it wreaked tremendous havoc on the Valencia area in particular. So I'll just play this video. I'll just play this loop a little bit more so you can see the movement of the air around the low pressure, the heat dome feeding moisture in over here, and the low pressure, and it doesn't move, okay? It was stable. It stayed in this position for pretty much all day, and it deposited vast amounts of rain on Spain. So let's have a look. We'll break it down and have a look at some more details of what happened. So this I tweeted out, and I'll keep this here, and I'll go to, I've got another view of my Twitter, twitter.com, Paul H. Beckwith. And I've been tweeting a lot of stuff about this. So, there's like lots of pictures of, Spain's deadliest floods in decades. I think this is a very telling image. It shows before and after. So you can see, there's a lagoon here. And I think Valencia is up here, and you can see this whole area became flooded out. Okay, vast areas got flooded out, and also in, of course, the city itself. And it's just like apocalyptic scenes of debris carried through the roadways, and you can see, I think you can see this level here would be the level of the water at the peak of the flooding, I believe, shown, on the walls. And they talk about it as the There's a local term that they use. They call it DANA, this D-A-N-A weather phenomena. One of the things that when I read some articles about the DANA is they can talk about this and they don't talk about climate change. So they can say, oh, it's just this weather phenomena, right? Which is kind of ridiculous. Look at this is like, it's like Photoshop. It's not Photoshop. It happened. We were trapped like rats. Spain's floods bring devastation and despair. 630 millimeters of rain in this location, which is just a phenomenal amount of rain. Somebody put it in context with UK, official weather UK rainfall events. Highest 24-hour total, 279 millimeter. Highest any 24-hour period total, 341 millimeters. Highest 4-day total, 495 millimeters. Well, this all happened in one day, 630 millimeters of rain. Just phenomenal amounts of rain. Some places, I think, had even more. And, it just picked up cars. They floated away. They ended up upside down, combined, with other cars. Like, it's just, it was really, here's a street with the buildings and so on, and nothing left. Everything washed away with the rains. This is a radar from the European Meteorological satellite. Basically, a year's worth of rain fell on us in 24 hours. This is an animation showing thunderstorms with strong lightning activity, causing exceptional rainfall and flash floods between about midnight UTC and 10 today. This was posted on October 30th. So you can see, Spain and the motion of this cutoff low, and the right part here, the Mediterranean is very warm. There's lots of evaporation. So as the airflow comes this way, it picks up this tremendous amounts of moisture from the Mediterranean. That's a couple of degrees warmer than it's ever been. And, the moisture-laden air then went right over and deposited on the land. And this just was a stable, stationary system, which didn't move all day, and it just deposited rain in the same places all day. So that's sort of the weather parts of it. It was just, it was just unbelievable. And if you go on Twitter and just search for Spain, you can see some of the images of the flooding, and it's just like a Hollywood disaster movie. And this type of extreme weather event is just happening all over the world, right? There's no really so-called climate safe havens. We had Hurricane Helene recently. So this is more before and after. It zoomed out a bit. We've got Valencia up here. These extreme weather events are just, we're getting more of them, higher frequency of them. They're getting more severe. They're happening in places they never happened before. They're longer duration events. And they're a direct result of the slowing down and increased waviness of the jet stream because of the great temperature imbalance, with the poles warming much, much faster than the lower latitudes. I've been talking about this on my climate channel for many years. There's cars, these boat cars. They float for a while. The water came up so fast, the air was trapped inside the cars. A lot of them just floated, nose down if the engine was in the front. Right, but the water just carried them through the streets. It was such a surprise the water came up so fast. It's just crazy. Raging torrents of muddy water. Here's how quickly the water came up in this video. You can just see, there was nothing there, and the water is just plowing down. It has to go somewhere. It goes to the lowest points. Look at the water coming in. It was just, how do you get out of the way of that? It was just, the rise was incredibly fast. right? And then it just kept rising and rising, and then taking out bridges and cars and houses, everything in the path, right? It was just unbelievable. I think there's an image here. Here's an image of it coming through some of the flat ground areas. I guess this is wood and debris that's being carried from upstream of wherever this was. I mean, it's just just crazy footage. And I think there's one of a bridge that was taken out at night. Yeah, there's lots of radar images and waterfalls and stuff. It's absolutely horrendous. There's a bridge. Oh yeah, here it is. Okay, look at this. Look at the water coming up, reaching the bridge and just knocking the bridge completely over. Massive climate chaos. That's what we're seeing here. So some of the articles, you can look through many yourself. I mean, I'm not going to dwell on that. I'll just sort of touch on some of the highlights. We were trapped like rats. Spain's floods bring devastation and despair. Some places were hit with a year's worth of rain in just 8 hours. They'd been in a drought situation, so the ground was pretty hard, not conducive to infiltration of water, lots of water, and the rain came down so quickly, it just overwhelmed any infiltration of water into the ground, so it just all became surface water, ripping down developed areas of Valencia, just bringing cars and creating utter havoc for people, right? When the rain started on Tuesday in the dawn, there were downpours. People were thankful and grateful because it hadn't rained for a long time. So when the longed-for rains finally reached the town in the drought-stricken eastern Spanish region of Valencia, they were merciless in their abundance. People were very happy at first because they'd been praying for rain as their lands needed water. But by 12 o'clock, the storm had really hit, and they were all pretty terrified. It got worse and worse, and, it must have been horrendously loud with all of the cars being carried through the street. The rivers overflowed their banks, sent cars and rubbish bins surging through the streets on the muddy floodwaters. This is a damaged rail line, complete and utter chaos and destruction in this region. I mean, it was crazy. I mean, here's a map. In 2019, just before COVID hit, I was fortunate enough to go to the climate conference in Madrid, Spain. So in the capital here, and Valencia is over here on the coast. And the devastation came very quickly, and was completely unexpected for people living in that region. So this is an image here of okay, so what there is what's going on here. Okay, so this is just posted today, or late yesterday, in pictures, Spain's deadliest floods in decades. So I'll just show some of the images. I mean, this is the most startling of the cars, all piled up like toy cars on the street, all thrown about, and the wood from surrounding parks and etc. just picked up and carried in the floodwaters, huge amounts of mud. I mean, look at this. Look at the water flow is here. It just, wreaked havoc on everything and everybody in the path. Right, there's lots of images of, the anguish on people's faces, the mud carried into homes, and, this, I think, I'm not sure if this is a car or what. Like cars sink people, buildings thrown like matchsticks and piled up, just horrendous devastation. There's like 30 pictures showing the some of the damage here, and riverbanks washed out, and you can see how high the water came up on the a lot of the walls of the buildings, abutting the streets. There's loads more pictures of the devastation. So just totally catastrophic. The death toll updated just before I shot this video, 158. I'm sure it will climb much higher. I mean, they'll probably find lots of bodies underneath the mud. It's among Europe's worst storm disasters, right? So devastating rainfall amounts, devastating flash floods. Teams are still looking for those missing, and it could become Europe's worst storm-related disaster in over 50 years. Okay, a year's worth of rain fell in 8 hours in parts of the Valencia region on Tuesday. The tragedy is already Spain's worst flood-related disaster in modern history. Meteorologists say human-driven climate change is making such extreme weather events more frequent and destructive. Okay, and in 2021, 185 people died in heavy flooding in Germany, 209 people in Romania, 1970, Portugal, 500 people, right? I mean, we're getting more and more events, and they're causing more and more destruction of people and their livelihoods and their jobs and where they live. Climate Central said in a report on Thursday that a low-pressure system behind Spain's floods had tapped into an atmospheric river carrying excess moisture from the unusually warm tropical Atlantic, right? So I showed you, that, I mean, the key graphic I've already showed you. It's right here. So it shows you the pathway, and whenever these wind patterns go over water, they over say the Mediterranean or the Atlantic, they pick up moisture because of very high sea surface temperatures and all that. For every degree Celsius rise in temperature, the air can hold 7% more water vapor, and that water vapor rises by convection, and then it condenses out into water droplets and creates clouds, and it releases all the latent heat that's stored, so it releases huge amounts of energy to fuel these massive extreme weather events. So, human-caused climate change is making it's elevated sea surface temperatures. So it's making at least 50 to 300 times more likely, it says. It's the sea surface temperatures, and then there's more evaporation from warm oceans, hot sea surface temperatures. So there's more water vapor in the air. That water vapor can create these atmospheric rivers and be guided by jet streams, and this is precisely what we're seeing in this catastrophe. So here's a map of Spain. Madrid right here, Valencia here, and I looked at the topography. So I got a topographic map from Wikipedia, and I enlarged it. So here's what you can see. So you can see Valencia here. The scale is down here on this side. Okay, so this is height in meters. So the green, 0 to 50, 50 to 500. Okay, so in the coastal regions, it's lower elevation. Okay, so that cutoff low was looping this way, bringing really warm. The Mediterranean off the coast here is much warmer than normal. There's a lot more evaporation, so the air, as it moves in this circular pattern, counterclockwise because of the Coriolis force deflecting things to the right in the northern hemisphere, jet streams driving the flow up this way, and down below here, split jet stream, cutoff low forming, being stable, and it caused this huge catastrophe in Spain. So, and the water, any rainfall in these regions has to go somewhere. It goes into the rivers, and it floods out. We saw the whole vast area here flooded out, basically, in the before and after split screen pictures. So we can, let's see, we can, drop in size here. So we're talking about this region here, and you can see, the coastal lowland regions is where the water had to go, right? Can't overcome gravity. Now, interestingly, this is a Reuters article. What caused the deadly floods in Spain? This is an article from today. The impact of, there's a phenomenon called Dana, which they're saying, hey, that causes it. Now, they don't really mention climate change that much here. They just say this storm was caused by Dana. Well, isn't that convenient? Right? So the Dana is a Spanish acronym for high altitude isolated depression, basically a cutoff low. Cold air blows over the warm Mediterranean waters, causes hotter air to rise quickly and form dense water-laden clouds that can remain over the same area for many hours, right? Because, well, we had a cutoff low. We had the jet streams being wavier from climate change. We had a cutoff low, and we had stability or a stuck blocked pattern in the atmospheric circulation pattern over this region. So it meant that we had a long duration extreme weather event. And of course, with the warmer sea surface temperatures, there was way more moisture feeding this thing. Okay, so they say that eastern and southern Spain is particularly susceptible to this phenomena due to its position between the Atlantic Ocean and the Mediterranean. So warm, humid air masses and cold fronts meet in a region where mountains favor the formation of storm clouds and rainfall. Right? So they're saying that, this is because of, this is something that's kind of unique to Spain. Well, they call it Dana, but, it's just a meteorological cutoff low. And this can happen just about anywhere, depending on the configuration of the jet streams, right? There is a terrain effect, topography effect, but, this whole thing has fingerprints of climate change all over it. And they'll be doing climate attribution studies and say that this event is like 5 or 10 times more likely to happen because of climate change, right? So those things will come soon. But, the term Dana was coined in the early 2000s. I'd never heard of Dana before this happened. It's new to me. It sounds impressive. Sounds like it could be a weather event and not climate related, but, that's very misleading if one thinks that. So the Dana term Dana was coined in the early 2000s. Any heavy rainfall in the autumn, characteristic of the Mediterranean climate, used to go by the popular name Godofrea cold drop in Spain and parts of France. Term still widely used colloquially. It means, it's like the idea of it is a cold air drop, high altitude disturbance, right? Closed high altitude depression that's become isolated or separated from an associated jet stream. Well, meteorologists around the world call this thing a cutoff low. Okay, so, it happens many places around the planet. It's only called Dana, I guess, in Spain. Okay, so that's the point. And it's, climate change is making these things way worse. This article talks about some of the, this talks about climate change a bit more. Scientists trying to explain what's happening, especially with a spate of deadly European downpours, see two likely connections to human-caused climate change. One is that warmer air holds and then dumps more rain. The other is changes in the jet stream. Okay? So at least they talk about the key things. They also talk about Dana here in this article. But then they get, Jeff Masters with Yale Climate Connection saying, if we're getting all the dryness, someone else is getting all the rain. The same extremely wavy jet stream that's causing the U.S. drought is also responsible for the horrific flooding in eastern Spain, says climate scientist Jennifer Francis. So this is good that she's quoted. She's with the Woodwell Climate Research Center in Cape Cod. She's a pioneer in a theory that attributes a wavier and slower moving jet stream to climate change because the Arctic's warming so much, it's no longer a lot colder than the rest of the planet. That theory is gaining more acceptance, but it's not fully embraced by the climate science community. I think it's pretty obvious that that's happening. But they'll do studies, attribution studies, and I'm sure they'll come up with numbers. This is a kid's doll, by the way. It's a pretty horrific looking picture. You know, you look at it and you think that's a real baby, but it's a dummy. It's a kid's doll. They quote, they've managed to find a guy who isn't fully sold about the wavy jet stream theory, but he ticks off the cutoff low storm systems. So he's saying it's attributable to that. Well, hey, guess what? Cutoff low storm systems are happening more and more often because of jet stream waviness. I think studies conclusively show that. You know, there was October floods in the Balkans. There were in September, parts of Poland, Germany, and Czech Republic got 3 months of rain in just 5 days. Right? I mean, this is a year's amount of rain in 8 hours, 10 hours, etc. Like, it's just, They talk actually about the Clausius-Clapeyron equation. For every degree Celsius the air warms, it can hold 7% more moisture, right? 4% more for every degree Fahrenheit increase. The world is warmed, now it says 1.3 because of greenhouse gases. That's over the 1850 to 1900 sort of baseline. And we've actually had a whole year above 1.6. So this is, you know, if it was 1.3, you know, if it's 1 degree Celsius, it's 7%. So 1.3, they say it's about 9 to 10% heavier rain. So this is the World Weather Attribution site. Looks for human fingerprints in extreme weather. You know, they'll have something out within a week or two on this event, and they'll probably say, hey, it's 5 to 10 to 20 times more likely to have happened because of climate change. All right, I'm sure they'll come up with something like that. So the air is holding more moisture is just for starters. When moisture condenses, it releases the latent heat energy, goes into the storm, invigorates it, increases its updrafts, pulls even more moisture from a larger area, and that could boost rainfall as much as 20%. So it kind of feeds, and you get a vicious cycle, a vicious positive feedback loop, amplifying small disturbances. There was a similar storm in 1957, but this year's storm was much, much wetter. The 1957 storm dumped 250 millimeters of rain, or 10 inches, but here we had at least 490 millimeters, 19 inches in just 8 hours. Okay, there might be rain gauge issues. I think some areas have even more. I already showed you. I think it was over 600 millimeters or 630. And you also have a very warm or toasty Mediterranean Sea. So the Mediterranean Sea had its warmest surface temperature on record in mid-August. The mean temperature was 28.47 Celsius. So that means there's more evaporation. This facilitates a greater uptake of moisture in the air, resulting in more rain when the atmosphere starts to cool in the autumn. So Spain needs to embrace itself for continued, I think, embrace itself, not embrace. Brace itself for continued heavy rain within the next few days. Okay, so the attribution studies will come out, but I mean, climate change is behind this for sure. You can go on Earth Null School, and you can look at the air, the wind, overlay wind. This is looking at 250 millibar, looking at the jet streams, and you can see the jet stream coming down here, and it kind of splits. Or there's a northerly one, which is very wavy, and a southerly one. This one here is driving moisture down this way. We've got Spain sitting right here. Okay, so, and then you're getting this cutoff low here occurring, getting moisture from the very warm Atlantic, getting moisture, the northward branch here of the wind goes over the Mediterranean, very warm, bringing the moisture up here into Valencia region. And you can this is October 29th, midnight local time, and then you can loop forward an hour, and you can zoom in on the region, and you can see how the cutoff low progressed, and how it was so stationary. I mean, you can't see it moving. It's just sitting there, acting like creating a fire hose, connecting the Mediterranean moisture to going over the land in Spain. I mean, it's like just like a big, huge fire hose, just pumping water there for long duration, setting all these records, wreaking so much havoc on people's lives in that particular region. So this is Earth Null School. Make sure you check it out and play with it if you haven't. There's loads of information you can find on that. There's also Climate Reanalyzer. This is what's happening right now, Thursday, October 31st. You can see what the jet stream pattern is still kind of there. It's kind of split into two. So hopefully we don't get another. There is a low shown here, but hopefully, we don't get another repeat of this event. I mean, if you just Google Valencia, Spain meteorology, they talk a lot about Dana, is mentioned quite often. And if you look at some of those articles, some of them actually, they basically say, yeah, this flood occurred because of Dana, and they have very little connection to climate change. And this is just very bad reporting in that case. Okay, and this is Live Science. What is Dana? The strange weather phenomena that's caused deadly flooding in Spain. So this is a science site with record high Mediterranean temperatures and a year's worth of rain falling in mere hours. Spain's been devastated by the weather phenomena known as Dana. Okay, so let's see if they talk about climate here. Tuesday, October 29, some areas received the equivalent of a year's worth of rainfall in just a few hours, triggering massive floods that devastated entire towns, left thousands of people stranded. In some areas, rainfall reached up to 20 inches of rainfall, 500 liters per square meter. And of course, if you get 20 inches of rainfall, this is an American site, so it's in inches, right? An inch is 2.54 centimeters, or 25.4 millimeters. So this is over 500 millimeters of rainfall. And Dana, here's a definition: depression aislada en niveles altos, a Spanish phrase, and I massacred the pronunciation, I'm sure. It translates to isolated depression at high levels. So cut off low, a high level, so high in the atmosphere, cut off low. This was the most severe Dana recorded. And it's also known as a cold drop. It's when you get a mass of warm air colliding with a stagnant mass of cold air at an altitude of around close to 30,000 feet or 9,000 meters. Okay, they talk about the jet streams, and it's basically cut off low. So they talk about that, but winds stronger than that of a hurricane or more rain than a hurricane. They say that this forms only over Spain, but similar weather patterns called extratropical cyclones form in the Atlantic off Uruguay. See, this is very misleading. I mean, it's a meteorological cutoff low, and it happens many, many places around the planet. And they're making it sound like a weather thing unique to Spain. So this is the problem I have. But then they talk about climate change. Okay, so at least that's good. They talk about the Mediterranean Ocean temperatures. Since the 1980s, the average temperature of the Mediterranean has increased by 2.7 Fahrenheit or 1.5 Celsius. That's almost double the rise in air temperature in the region over the same period. Summers on the Iberian Peninsula have seen record temperatures. Sea surface temperatures have exceeded 29 Celsius. So the timing of these Dana events is altered, they're saying. There's 15 to 20% more of them each year compared to 6 decades ago. So this gives you an idea as to how more common they're becoming. And climate change will likely fuel more frequent, intense, and exceptional precipitation events. So they do bring in climate change here after they emphasize the weather parts and explain what the DANA stands for and is. But yeah, it's a very cutoff lows happen often. They happen more and more often with the very, very meridional or wavy jet stream, wavy in the north-south direction, which again is a direct result of the warming temperature imbalance. The poles are warming much, much faster than the lower latitudes. The Arctic temperature amplification is at least on average 3 times the lower latitude warming. If you go to the high Arctic, it's 5 to 7 times. So because the Arctic is warming much faster than the lower latitudes, it lowers the temperature gradient to lower latitudes. So the jet streams slow down and get wavier. It's just basic physics. And, with much wavier jet stream, you can get many more of these cutoff low phenomena, which we've just seen, in Spain right now. So, yeah, horrendous extreme weather events happening around the planet. While this was going on, we had this massive typhoon just going into Taiwan. I guess I should probably do another separate video on that. Anyway, please consider supporting my research and videos by going to paulbeckwith.net and donating to my PayPal to support my work. And I will be heading off to Azerbaijan in less than 1 week now. And there's a GoFundMe. The link will be in the description, where I'm trying to raise money to cover my out-of-pocket expenses to attend this climate conference, basically airfare and lodging and some food while I'm there. So anyway, thank you for watching. And we're getting climate chaos in the climate casino, and many so-called climate havens, where people think, I'm good living here, I can avoid most of the problems from climate warming. Well, you've got another thing coming, I think. I think that's what all these events are showing. So thanks again for listening, and bye for now.